video will illustrate the different decays series or the decay processes for gold with a mass of 200. Now, these are not necessarily natural decays for gold, which is a good thing. But to start off with, I would have gold, so I know that I would have the element Au, and its mass is 200, so that goes on the top, so write the mass number on top. And then I need to look up Au on the periodic table, and I see that it has an atomic number of protons is 79. So then I just need to decide what kind of decays I'm going to go through. So the first one it wants me to go through is alpha decay. So I know an alpha decay always emits 2 protons and 2 neutrons. So it goes back 2 on the periodic table. And so it's an alpha particle. He42 is an alpha particle. And I just do the math. What plus 4 has to equal 200? Well, that's 196. And what plus 2 equals 79? And so that's 77. And so then I go and I look up element 77 on the periodic table, which should be 2 back on the periodic table from gold, and it's IR. So we're going to do the same thing again, just starting with gold again. So gold, 279. But this time I want to go through beta decay. So beta, the particle I know for a beta is an E0 negative 1. So what happens there is a neutron actually becomes a proton by emitting a beta particle. Excuse me. And so I do the math. What plus 0 is equal to 200? Well, easy math there. 200 plus 0 is 200. But then this one, people kind of get confused, is that I'm adding something to a negative 1, so it has to be 1 higher. Remember, we made a proton, so we need to go 1 up on the periodic table. And so I have 80, so I look up, and my gold would actually become a liquid and become mercury. So then the next process is, again, gold. We're going to just always start with the same guy. So gold 279. But this time they want us to go through a positron decay. So positron particle is an E0 positive 1. So in this case, I'm going to go backwards, because in this case what's going on is a proton decides he doesn't want to be positive anymore. And so it emits, when it emits a positron particle, it becomes a neutron. So a proton becomes a neutron. So in this case, I'm going to have, again, the math, 200. And then what plus 1 is 79? Well, that went back 1, 78. And so in that case, I would have made some platinum. So then pretty much the same process, except just a different process, but the same result, is an electron capture. So what happens in electron capture is a proton pulls in an electron to become a neutron. But we still get a proton into a neutron, just like we did on the positron decay. But the difference is we're going to write an E0 negative 1. Just like in math, if we move the positive to the other side of the formula, it changes it to a negative. But the same result. 200 plus 0 is still 200. 79 plus a negative 1 is going to be 78. And so our result is platinum. So reiterate, this is He42. That's an alpha decay. That's a symbol for alpha. And then I have a beta decay. Then a positron decay, which is a positive beta. And then we have, I just kind of label it as an electron capture, EC.